The following featured presentation is part of the Skywalking Network.
Welcome to Star Warsologies. Star Warsologies is a podcast where the galaxy far, far away meets real-world science, technology, and academic fields of study. My name is James Floyd. I'm a freelancer for Star Wars Insider Magazine and StarWars.com.
I am Melissa Miller, and I am a freelance writer for Star Wars Insider Magazine and also a science communicator in my day job.
This episode, Star Warsologies, will be chatting about astrophysics. Our guest expert today is Dr. Lisa Will, resident astronomer at the Fleet Science Center in San Diego and professor of astronomy and physics at San Diego City College.
We talked to Dr. Lisa Will in our San Diego Comic-Con episode a little while back, and we discussed binary star systems and Kessel Run. So we're going to talk about some different topics here today because obviously there's lots of astrophysics topics. Welcome, Lisa. Thanks for being here.
Hey, great. Thank you for having me. It's great to be here.
Lisa, tell us a little bit about your background and how you ended up in astrophysics.
Well, to be completely honest, exposure to things like Star Wars and Star Trek when I was a child made me interested in space. And so when it was time for me to go to college, I ended up getting a Bachelor's of Science in Astrophysics from UCLA. And I continued on to get a PhD in physics with an emphasis in astrophysics from Arizona State. And during that time, as a graduate TA, a graduate teaching assistant, I discovered I love teaching. And so that's why I decided to pursue a teaching career. There's no better place to do that than at the community colleges.
Can you tell us what astrophysics is and how that differs from a field like astronomy?
So that's a great question. And honestly, I think nowadays we would use astronomy and astrophysics kind of interchangeably. It used to be more like astronomy was like almost more the acquisition of data. Astronomy is always the study of the universe, but astrophysics was more like you took a lot of physics classes and you got sort of hardcore into the data, into the theoretical modeling and all that stuff. Whereas astronomy was more the acquisition and description. But now if you're getting an astronomy degree, you're getting an astrophysics degree and vice versa. So I really think of them as being interchangeable now. And I think most people would consider that too.
Okay, that's good to know that, which sounds cooler and more impressive when you talk about it, astronomy or astrophysics?
Well, I like emphasizing the astrophysics considering how much physics I had to take. And I think sometimes people don't realize the technicality and the rigor of the field. They see the pretty pictures. And let's face it, I got into it because of the pretty pictures, right? So there's no shame in that, but you see the pretty pictures. And I think of that as being more of a gateway into the physics, as opposed to it being separate.
I like that. Got into it for the pretty pictures. There's so much that's true about that. But that also makes it relatively easy, I suppose, to share. You know, you said you like teaching, and I know you're also involved with a lot of science communication efforts and not just being on our podcast and our Comic-Con panel. But that is sort of a gateway then, right? To share. Everyone can see those photos from, the Hubble Space Telescope and just want to know more.
Exactly. It's hard to think of another science that consistently gets its data on the front pages of the New York Times or something like that, because of the nature of the medium of where we are looking out into the universe with cameras, whether they be visible light cameras, infrared cameras, X-ray cameras. We can actually give you visualizations of the data in ways that are really difficult for a lot of other sciences to do. So I think because people are taking astronomical data observations every day of their lives, even if it's just noticing, oh, there's more sunlight in the room right now, I overslept. I mean, like you actually do astronomy data all the time. So you have more of the language of astronomy at your fingertips than a lot of other scientific language gets into people's vocabulary. So yeah, I think there's also a community nature to it. We can all get outside and watch a lunar eclipse together, or there are opportunities for communal observations. And it just makes it a very interesting, although professional astrophysicists spend a lot of time just them and the computer, some of the large scale events are broad and open.
That's great. I love that.
Yeah, and it helps that the things we're looking at are so large, as opposed to everyone having to share a microscope or something like that. Galaxies are really, really big. We talk about Star Wars taking place a long time ago in a galaxy far, far away. What do you think "far, far away" really means?
So what's interesting for me is that if we're seeing a galaxy that's far, far away, by definition, we are seeing it as it was a long time ago because of the light travel time, so the look back time. So for me, I almost feel like we're watching the streaming video coming to us from that galaxy, that it's so far away that we're seeing it as it was a long time ago. And so I've always had in my head that we're looking at historical events somewhere else. And then, as we've been watching the Star Wars universe for the past 40 something years at this point. In terms of galaxy distances, the closest large galaxy to our own Milky Way is the Andromeda Galaxy. And that's 2.5 million light years away. And that's the closest galaxy, not including our own little companion satellite galaxies to the Milky Way. So when we look at the closest one to us, we're already seeing it as it was 2.5 million years ago. And that's part of what we call our own little local group of galaxies. We regularly see galaxies that are 10, 11, 12 billion light years away. When we're talking about how long ago could it have been a while. It could have been a while.
I love the idea that we're getting the equivalent of like historical documents and Galaxy Quest beamed to us that we're picking up here. Confusing with the whole prequel order and all that kind of stuff, but we don't have to think too much about that. And it always seems to arrive, on holiday or big box office weekends. But yeah, no, I like that. That's great.
For me, the streaming video analogy has helped teach look back time. I have been teaching astronomy since before these streaming video services existed. But now students understand you have to wait for the video to buffer, but once it gets there, it plays continuously. And so it's like when a star turns on, if it's 100 light years away, it takes us 100 years for that light to reach for us the first time. But once we see it, it's on continuously. We get that continuous signal. But it does mean that we're seeing events that happened a long time ago in that galaxy that is far, far away.
Right.
It's like a live webcam into the past.
It really is. I like to say that astronomy is a field where you watch the past as it happens.
Oh, yeah. I like that.
Yeah.
So I'm curious what is, 40 years away in terms of that feed. If we were watching something as it happened and it just arrived 40 years ago, where would that have been originating?
Well, there are several star systems that are within 40 light years of us. The closest star system to our own is the Alpha Centauri system, which is about 4 light years away. So there are many that could be streaming us Star Wars from nearby, but they are still be in our galaxy close by in our local neighborhood.
What are some of the similarities that you see when you're watching Star Wars to planets? I know we've talked with our ecologist about the whole one biome per planet thing. How much of that is seen in real life?
Well, it's interesting because I know Star Wars sometimes gets disparaged with how every planet just has one biome. But if you allow yourself to also think of moons or allow yourself to think of small planets, free yourself of being geocentric and you're thinking about what a planet might be, then you open up the idea of these monoclimates. So many of the moons in the solar system are monoclimates because they're small enough that they basically get the same angle of sunlight from the same direction all year long. And it helps when they're 5-10 times further away from the sun than we are, like when you're out at the orbits of Jupiter and Saturn. Large planets close to their stars, especially if they're at a tilt, they're going to have seasonal variations. They're going to get different angles of solar illumination, and they're more likely to have varied climates over their surface. But for me, the biggest problem with these planets in Star Wars is that every planet appears to have a breathable atmosphere that they land on. You don't see them, with the exception of in The Empire Strikes Back, when they're actually ended up being inside an animal. We tend not to see them put on breathers, right? And then all worlds appear to have comfortable gravity, which is also something that is not very likely to happen. But the visualizations of the worlds we see, so many of our heroes' worlds, like Alderaan and Naboo, they look like Earth. Jeddah and Jakku and Tatooine kind of look like Mars. I see a familiarity in these worlds.
Right. And some of that's probably just, filming locations. Tunisia can look like Mars. I think there's maybe some more of that in The Mandalorian now, where they're using that totally different visual system, where they're getting some slightly more varied options on screen.
If I could have one wish for myself for the Star Wars universe as a fan, I would love to have some time in the volume. Yeah. That I think that is such amazing technology. I spent a lot of my life, luckily, under a planetarium dome. And I know how transporting it can be. Like, I can have a day at work where I don't get a chance to go outside, but if I spend a little time under the stars in the planetarium, I feel like I've been outside. I so desperately want some time in the volume and have them turn on Tatooine so I can be on Tatooine. That's one of my fandom dreams now.
No, I like that. That's a great dream. That's a business right there. They could put, up little mini versions of that at conventions and stuff like that. People would absolutely pay $20 to spend 5 minutes on, planet of your choice.
Absolutely. I would give so much money for that.
What do you think it would take to support life on a moon? We see Yavin 4 in A New Hope and Rogue One, and then we see the forest moon of Endor in Return of the Jedi. What do you think it would take to make that really possible?
What's interesting about moons is that they have to necessarily kind of be smaller than the planet that they orbit. So you're not going to get the moon around Yavin 4, right? You're not going to get that moon around Earth. We do have large planets in the solar system. Ganymede of Jupiter is the largest moon in the solar system. It's larger than Pluto. It's larger than Mercury. If I took Ganymede and put it around the sun, you'd be like, oh, look, a planet. But it doesn't have an appreciable atmosphere. Titan, however, of Saturn, which is also larger than Pluto, it's about the size of the planet Mercury, has a largely nitrogen and then lots of interesting hydrocarbons in its atmosphere. It has a thicker atmosphere than the Earth. We can imagine situations where we could have life-bearing moons, largely dependent on where they are in their solar system. Because Titan is the size of Mercury, roughly, Mercury doesn't have an atmosphere, or at least not an appreciable one, largely because it's so close to the sun that the average temperature of the particles out there would have them moving at velocities that its lower gravity would have a hard time keeping. It's something called the escape velocity. This, you have to wonder, will the molecular speed be going faster than the escape velocity of the world on average? It makes it hard for it to retain an atmosphere. Put it further out in the solar system, Saturn is 10 times further away from the sun than we are. It receives, therefore, 100th of the light from the sun. It's a little bit easier for a world that size to hold on to an atmosphere. I think there's always a way that you can build a moon or a world that would work. Is if that was my assignment, tell me the temperature of the star. I can tell you kind of where to put it, what it'd have to be made out of, its gravity. We could make it work. Whether or not life would evolve there is another thing, right? But we could give it the building blocks. We could get it started at least.
So realistically, what would it look like to you if you were watching Star Wars in order to not notice what you're talking about in terms of, everywhere seems to have the same gravity and breathable atmosphere? I mean, obviously the breathing mask like they use when they're on the asteroid, but that's pretty much it in terms of adjustments that our main characters need. At least I know there are some other characters that wear masks or wear, goggles or something like that. But what else would be needed realistically?
We're actually just going to ignore the space travel part. Like, if we're ignoring the faster than light part, to be able to get you to jump around like this, for me, the hard thing would just be, how do you go from world to world and know that the gravity would be comfortable for you to live on? We already know here at our own solar system with long duration missions on the International Space Station that humans in microgravity, experience bone density loss and stuff like that. And so it's not necessarily going to be easy to, do a 3-month stint on one planet and then return to your home moon. When I'm looking at the individual planets and moons themselves, for me, that's actually the hardest thing to turn my brain off of and where I have to go. This is fantasy as opposed to more science fiction, because they just ignore it altogether. You don't ever hear anyone land on a world and go, oh, wow, I feel heavy. Either that, or we have to assume that their definition of a habitable world in the Star Wars universe has the same gravity, and that those small moons must be made out of something really dense to pump the gravity up.
Yeah, I definitely remember at the planetarium I grew up going to at the California Academy of Sciences up in San Francisco, there was a scale that you would stand on, and then you could cycle through all the different planets and how much you would weigh on the different planets. And that's a really cool visualization. But how it just in the planets that we know here in our solar system, what are some of the differences?
So in terms of the worlds that you could stand on, we're going to talk about the terrestrial planets, right? And perhaps some of the moons. So on the moon, that's 1/6 Earth gravity. Mars would be closer to 1/3. Venus is almost our twin, so it would be about 90% Earth gravity. So that's, your weight fluctuation over a couple of years for a lot of people. So you wouldn't really notice anything there.
And then you would fry.
And I'm not advocating for anyone to go to Venus. I always tell my students it is the nastiest place of the solar system. People and Venus do not go well together. And then in terms of the moons of the outer solar system, whereas that gives us some of those monoclimates that we're talking about, because further away from the sun, ices could hang around longer. What looks like rock in some cases is actually a rock and ice mixture. So the actual rocky material is lower density. So the gravities are lower, even if they might be similar sizes as some of the denser worlds further in the solar system. So our moon and Europa don't necessarily have the same gravity, although they're very similar sizes.
So what's the difference between a planet and an exoplanet?
The definition of a planet is a world that orbits a star. Its gravity must be sufficient enough to have forced it into a spherical shape. And so that's how we talk about the size of the planet. And the International Astronomical Union says it must have swept its orbit clean. I like to rephrase that. I like to say it must be the dominant thing in its orbit, because we haven't swept our orbit clean, because we sweep up meteor shower bits once a year at every time, right? So we're still sweeping our orbit clean. The idea is that any big objects we would have encountered already, and we're still here is the idea of that definition. An exoplanet would satisfy that same definition just around another star.
So in the galaxy far, far away, really all planets are exoplanets to us.
Exactly. All of those planets are exoplanets because they're not orbiting the sun, our sun.
So at the end of The Empire Strikes Back, we see the Rebel fleet and they look out and there's this galaxy pretty much out the window of the medical frigate. You see the ships kind of in front of it. Are they at the edge of their own galaxy, or is that kind of a galaxy within a galaxy type situation, you think?
That is a fantastic question. And I have spent a lot of time since 1980 wondering what that last thing was supposed to depict, because it looks like a galaxy. But if it is a galaxy, then they're outside the galaxy. Did the Rebel fleet have some sort of, this is where we're all going to get back together if we get separated sort of jump point outside the galaxy? That's one possibility. Another thing it could be attempting to visualize is a star in the process of formation. And back in 1980, when that was developed, our thoughts about what that might exactly look like would have been a little different, but not that bright. Still wouldn't have probably been that bright. So I think they were probably supposed to be around a forming star, but visually, they're outside the galaxy looking back.
Is it impossible at all to have like little galaxies within a larger galaxy? And could that be the case for this rendezvous point?
So galaxies occasionally eat other galaxies. We call this galactic cannibalism. I'm not even kidding. Yeah, the galaxies can gravitationally attract each other to the point where they merge. But during that process, their shapes morph. The gases in them usually get stripped out. The Milky Way is in the process of eating at least one currently, but they wouldn't look like that pristine, lovely little galaxy anymore. So if we're seeing something with an accretion disk orbiting a central blob, that would have to be on a much, 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 much smaller scale for it not to be warped apart. So I guess one way to say it is there'd be no pretty galaxies inside another galaxy. It would be messed up after having been eaten. We've probably done our fair share of eating other galaxies.
So there'd be nothing as cinematic as that final shot in Empire Strikes Back. So.
Right, which is for me why that has to be some sort of other different phenomenon. And so in my head, I'm just like, well, that's just a young star that has turned on, but has not yet had its planets form. So in my head, that's an accretion disk around a forming star, even though the visualization of it is definitely a galaxy.
What is an accretion disk?
An accretion disk is the name of a disk of material around an object. It could even be a black hole, but a gravitationally bound disk of material that is either accreting or falling upon the central body, or the material can be coagulating into and sweeping its orbit clean and getting bigger and making planets out of it. So we can have that disk that you see around that central bright blob at the end of Empire Strikes Back. If we came back 100 million years later, you might see a solar system.
As much as I have overthought so many aspects of Star Wars, I've literally never even considered that scene as being something that's not just like, ooh, pretty and roll end credits. So I love it. That's what this show is for.
One interesting way you mentioned it could be a star forming. The novelization of The Empire Strikes Back doesn't call it a galaxy. It just calls it like they're staring at a star. And I think it was because they didn't have the visuals yet for that, but it kind of ties back to what you're saying, that it's just a star in the process of being formed.
And honestly, because I voraciously read the novelizations when they hit the stand at the grocery store, that could very well be the first time I even thought as a kid. You know, I knew what galaxies looked like because I was a nerd, right? But maybe that was the first time I thought of it as a star forming. But I have been trying to resolve that, and I get distracted by it now, which is one of those few times in Star Wars where I get distracted. I'm much more likely to be distracted in other movies now by space visualizations, because I can usually say what Hubble Space Telescope image that they have just tweaked a different color, and I find that really distracting.
I recently watched Rogue One, and I think it's one of the opening scenes of that there's a ring system. And I never really thought about there being rings around habitable planets. And that's just my, solar system centric thinking. But they're not mutually exclusive?
They don't have to be mutually exclusive at all. So the weirdest rings in our solar system are actually around an asteroid, believe it or not, discovered a few years ago, where it's likely the result of an impact where the little bits of debris weren't going faster than the escape velocity, so they couldn't escape, weren't going so much slower that they fell back down, but going at about the escape velocity, so went into orbit. So you do not have to be a gas giant to have a ring system. The ring systems around planets are also gravitational effects. There are still some debate whether or not it's material that couldn't coagulate together, or more likely material that got broken apart. Icy objects that got so close to a world that the tidal forces actually broke the world apart. And then each of the little tidbits went into orbit around the planet like a little moon in and of itself. The analogy I tend to use is, you have probably felt safe crunching ice with your teeth, but not crunching rocks. Like, what is easier to shatter? And so the icier material is easier to shatter with tidal forces. And that's why ring systems can be so bright. So just because we don't see them in our solar system doesn't mean they can't exist. And I want them to exist so badly. Rogue One is the most beautiful of the Star Wars movies in terms of the environments that it created just for moments like that. That was really impactful to me. And I'm just like, that's gorgeous.
Speaking about rings and ice and stuff, we see Geonosis in episode 2, and Obi-Wan and Jango Fett kind of square off in space there. So we see a lot of rock-based stuff in the rings. That would it be possible to have just pure rock ones and no ice?
I look at that, and the way I justify it in my head, because I cannot stop trying to justify these things in my head when I watch these things, is that could have been the result of a collision. You could have had a rocky collision. But this goes back into, like, if you wanted it to be made out of rock, the tidal force or the gravitational force would have to be so strong that I'm not seeing Obi-Wan and Anakin being comfortable on the surface. So when they're walking around. And so that's the problem there. There's no reason why you couldn't make them out of rock. The way the tidal forces work is it's going to be easier to break apart things of lower density than higher density. So you could get it to work, but I think it's probably more likely due to a collision at some point.
So we had the planet Geonosis, and then finally someone put a ring on it.
That's a good one. I like that one, actually. Any Beyonce reference is a good Beyonce reference. Oh, man. So is there more to talk about in terms of asteroids? I'm really interested in the asteroid fields come up, here and there throughout Star Wars. Obviously, we talked about Empire Strikes Back a little bit. That asteroid had gravity even. Is that just a factor about how big it was?
Yeah. And so anything that has mass is going to have gravity. And so the more mass and the more concentrated it is in particular, because the gravitational force is a function of both mass and radius. And so mass and size. And so asteroids do have gravity. They tend to have lower gravity. But once again, you have a bigger one, you can get more gravity. Whether or not inside of it they'd be able to walk around comfortably, that's another question. So once again, it's the how strong the gravity is for me. The thing about the Empire Strikes Back scene is how close those asteroids are to each other. We don't necessarily see that in terms of large asteroids in our own solar system. There are gaps, but there are still some ongoing collisions. We have captured over the last few decades some images of asteroids with like almost looking like cometary tails, but that's likely of having been due to a recent collision. So it's still happening out there, but not like the asteroid belt seen from Empire Strikes Back. Otherwise, those probes that we've been sending out to the outer solar system would have had a hard time getting there. In fact, one of the goals of the old Pioneer missions, like the first one to Jupiter, was proof of concept. Can we navigate? Can we get through the asteroid field? Or is it just like as we have aimed between the large asteroids that we've been able to discover so far, will we be pelted by so many other ones that the spacecraft can't get through, like so many of the small ones? But that didn't happen. So there's big gaps.
We just go up and over it. Like, you talked about the accretion disk. So, that the asteroid belt is kind of in a disk shape. Couldn't we just kind of go up and over it to avoid it?
That's a good question. That just ups the amount of energy you need, which ups the fuel. You would have to be doing a lot of navigational changes on the way. And so the more changes you have to make, the harder it is. Think of the disk as being more like a donut. It would be a significant deviation above or below. And the lowest energy orbit is always going to be the one on the same plane.
Another asteroid thing, we're talking about Rogue One. We get this one shot of the ring of Caffrine, which is like two asteroids touching each other, or not touching each other, but have been built connected to each other. I always thought that was a beautiful and just really novel thing.
Cool. That's one of the best shots.
Could that work?
Wow, that's a hard one. The thing with these objects in space is even if they have low mass, if they're moving, they still have a lot of momentum, because momentum is mass times velocity. And so trying to grab stuff and hold on can be really difficult in space. Now, in terms of things coming together and coming into contact, though, we do see interesting objects in our solar system where it looks like two things have collided and merged. Comet 67P that the Rosetta spacecraft was following definitely had that look. And Arrokoth, which the New Horizons spacecraft went to after it went to Pluto, definitely looks like two things impacted and glommed on together. So can we get stuff close to each other? Yes. Could we hold on to them? That's harder.
Yeah, maybe not the best place to build your spaceport, though it did look really cool.
Yeah. Wow. Yeah. So it's the momentum there that makes things complicated.
I'm just thinking Arrokoth is such a cool name.
Yes. It is named after, I think it's the Powhatan tribe where Johns Hopkins University is located. It's basically a tribal land acknowledgement for the Spaceflight Center that's been running the mission.
Cool. Oh, nice. I'm curious if you're like me, you talk about the overthinking things and how you notice it, not just in Star Wars. For me, I just need like the one line to placate me. And, thank goodness we invented the blah, blah, blah. So I'm sort of curious if that would be enough for you too. If there was one line somewhere in a comic or a novelization that was like, oh, thank goodness everyone who adapted in this galaxy can go from planet to planet without, their spine shrinking or something.
I actually, the one line for me does work. Like the idea of faster than light travel in Star Wars absolutely works for me because they never acknowledge it. Han just reaches for that lever, pulls back, and it goes. They never try to explain it. And I am fine with the magic button. And so if they did have a one-liner like, oh, miraculously, somehow all of the habitable worlds in this galaxy just have a range of gravities that are comfortable for humanoids or something like that, I'd be totally fine with that.
Or maybe there's other planets that aren't, and there's completely different life forms, and they have their own separate empire. And Earth gravity type planets are in one connected system.
Yeah, I could see that because you wouldn't have the urge to take over worlds you couldn't use. If you just wanted to look at it in terms of empire motives.
Right.
You could always blow them up for, raw materials. So.
Right. Or here's one thing too, is like, how would atmospheric changes and gravitational changes affect droids? Is that just where you send droids to do your mining and those sorts of things? Because they don't have to breathe and they probably could weight themselves. So it wasn't as big of an issue.
Yeah, the droids should definitely be more adaptable. In fact, we see them outside of spaceships, like all the astromechs, right? They have to function both in space or in atmosphere. Low G, high G. It never gets acknowledged about the pilots of those spaceships, but the droids are all working in all of these different environments. So yeah, that absolutely could happen.
Well, I think back in some of the video games, they talk about a star forge and there's been all these in the past history, some ideas of ancient races that have, built up things. Could it be possible to basically drag planets around so that they are at the right distance to keep an atmosphere, or move planets and break them apart, or put them together such that they'd have the right gravity? It would take a huge amount of effort and energy to do it, but could you basically not terraform, but galaxy form?
That is a really interesting question. Could we make the Earth into Venus by moving the Earth closer to the sun? Yeah, I mean, that would just pump up the rate of the greenhouse effect, and then suddenly we would be Venus, right? The sheer amount of energy, like you said, though, that's going to be the stumbling block. How would you actually? I'm not the engineer. That would be the engineer's problem. I think physics wise, that would be possible, but unlikely. But movement within a solar system would definitely be easier than trying to be like, okay, oh, look, this star way over there. That would be a good star to have a planet around. That is extremely not going to happen, just in terms of the distances in between.
So if someone was going to get into physics, astronomy, astrophysics, how would you recommend going about that?
For me, I feel very fortunate that as a child, I was exposed to Star Wars because it led me into an interest of space very early on, so that I was self-directed. I was checking out space books from the library as a kid. My parents didn't go to college, so I was kind of on my own trying to figure out what I wanted to do and how to get there. So I just remember looking up the UC admissions criteria, or when I got into high school, and saying, what do I need to do? And so I took the math. I know that puts off a lot of people, but not falling behind in math turned out to be important. So I would always say, even if you're not enjoying your math classes, stick with them, because having the math background opens up a lot more doors than it closes. And then when you go to college, take the intro-level astronomy class, see if you like it. Also take the intro-level physics class, see if you like it. Not necessarily the one with the math, but the Physics 100, where you get a taste of all of physics just conceptually. Because the thing about astronomy is that you're really supposed to know a little bit of everything. There's the chemistry of the nebulae and the atmospheres. There's the orbital dynamics of the way, things move. There's the way fusion reactions power stars. It is such a broad field. And now when you bring in things like extremophiles and astrobiology, but there's also things that are a little bit closer to home, like archaeoastronomy and understanding humanity's connection with the sky. There's so many ways you can take astronomy. And don't neglect your writing skills, because scientists communicate a lot via the written word. And that is also incredibly important. And go visit your local science museums when you can. That'll also help you figure out what you want to do too. Science communication is a big part of my career. I actually see sometimes being a community college science professor is a science communication job in a lot of ways too, because we get so many students, and this will be their one taste of science, that it's important to teach it as a SciComm course in many ways. But I'm involved in Astronomy on Tap, where we go out to breweries. I do con panels. I do informal talks at the libraries, because what I have found to be true over the years is that there's a huge desire for informal science learning. That if you offer a Comic-Con panel on the science of Star Wars, people are going to attend or tune into it. People want to learn science, and they also want trusted sources. And that's where the science communicators come in. And I think that is incredibly important because astronomy is beautiful. The pretty pictures make it easy for us to communicate our work. And also because truthfully, it's so expensive. There is a portion of every NASA mission where the funding is devoted to education and public outreach. They make the pictures, they put them up on the website for someone like me to disseminate. That's actually part of the goal. NASA is a taxpayer-funded organization. I think a lot of us feel an obligation to share what the Hubble Space Telescope is looking at, what the Chandra X-ray Observatory, what is NASA Mars Perseverance rover looking at today, because you have paid for it. You do deserve access to it. And NASA's actually, out of the world's space programs, actually really good about making this material available.
Lisa, where can we find you on social media, or do you have any upcoming publications or existing publications that people can check out?
Let's see. So on social media, I'm Dust Chick on Twitter, and that is a public account where it's mostly space and pictures of my dogs. I perform the Sky Tonight monthly planetarium shows at the Fleet Science Center in Balboa Park the first Wednesday night of every month. But for the most part, I am easiest to find teaching classes at San Diego City College and doing science outreach at the Fleet Science Center. Oh, and you can also follow Astronomy on Tap San Diego on Facebook and Twitter, as we are attempting to get back up and running after a 1.5 year hiatus due to the pandemic.
And you did virtual planetarium shows through the Fleet. Are those on their YouTube page?
Yes.
Okay. So YouTube Fleet Science Center, FLEET Science Center. Those will have your narration over them.
Yes.
Great. Well, thanks so much for joining us today, Lisa. I really appreciate all your expertise. And there was some of this part of the conversation I'd never even considered before. So thank you.
Thank you so much for having me. I always enjoy talking about space and all things Star Wars.
Well, thank you so much.
That wraps up this episode of Star Warsologies. We want to thank our guest, Dr. Lisa Will, and we want to thank all of you for listening, especially those of you who have connected with us on social media recently. If anyone else has a topic for Star Warsologies, or an expert we should interview, let us know. We're at Star Warsologies on Twitter and Instagram, or starwarsologies@gmail.com. That's Star Wars OLOGIES.
No topic is off limits, even the taxation of trade routes and outlying systems.
We're part of the Skywalking Network. You can also find a variety of other great shows about Disney, Star Wars, Marvel, including the flagship show, which is Skywalking Through Neverland. You can find all of those at skywalkingnetwork.com.
All right. See you next time on Star Warsologies.